Today's lesson is more multiplication with decimals. Today I'm going to show you a couple of different ways of multiplying with decimals. We've already talked about how to multiply with decimals using the area model. But now we're going to take a look at how other models can be used. So, first of all, we need to wrap our minds around why sometimes when we're multiplying a whole number times a decimal, we can end up with an answer that's smaller than one of our factors. Isn't that weird, Matthew?
Yeah, it's weird.
So we have to kind of think about what we've been taught by our teachers, who of course were very well-meaning when they told us,
the number gets bigger.
And all the kids, thinking that that was pretty easy to remember, just said,
Okay.
Unfortunately, however, that fact that our well-intentioned teachers might have told us is actually not true. Huh? All right, write this down. The whole concept of multiplication does not mean that the numbers are getting bigger and bigger and bigger. It just means that you have a certain number of groups, and each of those groups with a certain number of members in each group. Or, if it doesn't have individual members, it's a group of a certain size. Let's demonstrate this using money. We like money, don't we, Matthew?
Yes.
So, we'll start out small, just pennies. Okay?
Yeah.
Okay, just pennies.
How about 4 cents?
4 cents sounds good to me. So draw yourself 4 pennies. They don't have to be perfect. You don't have to get Lincoln's portrait just right. We can just label them with 1 cent so that we know that we are talking about 4 cents. So basically what we have is 4 cents. $0, 0 tens, and 4 ones. So 0.04. I'm sorry, not 4 ones, 4 hundredths there.
Yeah.
Because a hundredth is 1 cent. Now let's say that we had 3 groups of 4 cents. That would look like this. So what we've just done, and make sure that you're drawing this as well, is we've made an array. There are 4 members in each of 1, 2, 3 groups. So it's basically like we have 4 cents 3 times.
Yeah,
So-
like 3 times 4.
Exactly. So we would have 3 groups of 4 cents. So Matthew, we'd have 3 times 4 pennies, but how much is a penny worth?
A penny is worth only 1 cent.
Yeah, so it's 4 hundredths of a dollar. So our multiplication problem really would be 3 times 0.04. Now we can do this in our head and we know how many pennies are there. Matthew, how many pennies do we have?
We have 12 cents.
Good. But wait! My teacher said whenever you multiply the number gets bigger. And I said, okay, but 12 cents or 12 hundredths is not bigger than 3 whole. So what we're doing here is we're just saying we have 3 groups of 4 cents.
Yeah.
So it's kind of like 4 cents plus 4 cents plus 4 cents makes 12 cents. So that's why a decimal product could be less than one of the factors that you started with. All right, let's show this with the traditional algorithm of multiplication. With our traditional algorithm of multiplication, we would just put the numbers in all lined up along the right. We are going to worry about this decimal point later on. We can plug it back in all at the end. So, and we'll see why that trick really works. This is the way that we were always taught, but maybe we don't know exactly why it works. So let's distribute our 6 to the 8 tenths and to the 3 whole numbers. So, first of all, let's distribute the 6 to the 8 tenths, and let's not worry about that decimal place right quite yet. So let's just plug that back in at the end. So 6 times 8 is...
48.
You got it. Write down the 8 in the ones place, and I can carry my 4 that's not really a 4 because we're messing with place value here. So really what we're saying is that 6 groups of 8/10 would really be 4.8. It would be 48/10, which would spill over into 4.8, or could be rewritten as 4 wholes and 8/10. So that's why our 4 can spill over here to our ones place. All right, now we can distribute. Now we can distribute our 6 to our 3 wholes. So 6 times 3 is...
18.
Good. Plus 4 more ones. 18 plus 4.
22.
You got it. 22. Okay, now we have 228. Does this
Make sense?
No. If you have about 4 times 6, we really should have somewhere around 24. Yikes! 228 is nowhere near 24. So we have a problem here based on our estimation of 4 times 6 being 24. So what we need to do is we need to take a look at our place value, that fantastic little decimal place, or that decimal point right there. So what this means by ignoring this right now is we've kind of cheated. What we need to do is we need to say, well, how many places have we cheated over in our factors? So what we can do is we can take a look at our factors that include decimal points, and we can say, oh, we've cheated over 1 place. We've done a power of 10 cheat. So we need to uncheat ourselves and put the power of 10 back. We will do that by uncheating by a power of 10. We pretended like that decimal wasn't here in our factor, and we pretended like that was a 38. We cheated it up by a power of 10. We can't do that, can we?
No.
Not unless we make it right at the end by cheating back a power of 10. Now at this point, a lot of students think, oh, you just drop the decimal point down. Well, no, it doesn't quite work that way. Let's see how this works with another problem. You wouldn't normally learn this until 6th grade, but you get to learn it now.
Yay!
What if we have 2 7/10 times 4 9/10? Well, let's do an estimate really, really quickly. 2 7/10 rounded to the nearest whole number would be...
3.
3, that's right, it would be a 3. And what about 4 9/10 to the nearest whole number?
5.
Okay, and 3 times 5 is...
3 times 5 is 15.
Okay, so our estimate needs to be, or our estimate is 15, and our answer needs to be close to 15. That's going to help us as we uncheat our decimal places at the end. Well, first of all, take a look. We're cheating here with 1 power of 10 and another power of 10. We're cheating with 2 powers of 10. Let's keep that in mind as we work. We can pretend that it's not there right now as long as we put back those 2 powers of 10 in the end. All right, so let's use what we've learned about the traditional algorithm of multiplication to start multiplying. Here we go. 9 times 7 is 63. You can write down the 3. And we can carry the 60. Now remember, at this point, our place value is all messed up, but it's okay because we are going to put it back later on. Okay, and now we can distribute the 9 to the 2. 9 times 2 is... 18.
18.
Plus 6 more would be 24. All right, now we are going over to the next place. So that's when we're going to drop our 0 here. We're going over to that next place. We know we're not going to have anything of value in that first place, so we can put it as a 0. Now at this point you might be thinking, well, what about the decimals? Well, are we done yet?
No.
So we can't take care of our cheating until the very, very, very end. Then we'll figure out how to undo our cheats. All right, now we need to distribute the 4 to the 7 and the 4 to the 2. So 4 times 7 is 28. You can write down the 8. Ooh, we need to get rid of this. We're done with that plus 6. It was a 28, and now we can do our plus 2. That spilled over. Now we've got 4 times 2 is 8.
8.
Plus 2 that spilled over is
10.
And we can write our 10. Okay, next step, add those partial products. Uh-oh, Matthew, we have a problem. Looks like 1,323. Ah! That's not close to 15. But remember how we cheated at the beginning?
Yeah.
At the beginning, we said, hey, we have 1 power of 10 cheat here and a power of 10 cheat here. By ignoring those, we basically said, hey, let's pretend that this is a 27. We cheated by basically multiplying by 10. It was a times 10 cheat. Write this down. And we also cheated in our second factor by a power of 10 by ignoring that decimal. We pretended like it was just a 27 and a 49. We made those numbers a lot greater than they should have been. So now we have a times 10 and a times 10 cheat to take care of. So let's take care of it with some butt cheeks.
Yeah.
Okay, so here's 1 power of 10 cheat taken care of. Here's another power of 10 cheat taken care of. And we can place our decimal. Now right away, we can see what I was talking about in the last problem. We don't just drop the decimal down. If we did that, we would have only taken care of 1 power of 10 cheat. But we cheated twice by a power of 10, so we have to move the decimal twice over. Okay, now we can ask ourselves, does this
Makes sense.
Let's take a look. Our estimate was 15. What do you think, Matthew?
We think, yeah, pretty darn close.
Pretty darn close. I agree. So our final answer then would be 13 and 23 hundredths. That's a 6th grade math problem. So if that's making sense to you and you're able to do that, congratulations. You have mastered 6th grade math. All right, I'm going to give you a task to do now. Estimate and then solve for this lovely problem about animal speeds. What's the maximum speed of a chicken if it is 300 times faster than a garden snail, which has a maximum speed of only 3/100ths of a mile for every hour? So the snail's pace is 3/100ths of a mile per hour. We're going to need to multiply that times the chicken, which is 300 times faster. So set up your estimate and then solve. You'll be comparing your answers to your group tomorrow. Be careful with how you cheat with powers of 10 and put it back at the end. Ooh, and if you want a really, really, really good challenge, here's a challenge task for you. You can pick.
Dun dun dun. What? I can't do that.
Yeah, you can. Just line them both up on the right. Ignore the decimal for now and think about how many places over, how many powers of 10 you cheated by, and you can put that in at the end. You can do it.
Yeah.